Hello everyone. Hello, am I audible? Please confirm. Someone in the chat. Okay, okay. Hello Sanidhya. Hello Vishal. Hello everyone. So we'll start in 2 minutes. Let everyone join. I gave you one homework problem yesterday. Did you guys try it? Hello Dev. Good morning. Good evening. Hello Karthik. Good evening. In the meantime, you guys can try the house robber problem I gave you yesterday. You guys can think of the ideas. What's the idea you are getting in that problem? Yes, exactly, Phoenix. House robber problem. Today we will do some more problems on 1D DP. We will just see how our understanding is in 1D DP. Then we'll move on to 2D DP. We'll do some problems. Actually, it's just a extension of 1D DP. You guys will be able to catch it right away. And then towards the end, we will try to see how do we solve questions from DP on subsequences. Can you pick and not pick approach? Okay. Yes, Madan, you are kind of there. Yes, you are close. Hello, Chaitanya. Hello, Ayushi. Good evening, Sarvanthi. All right. So I feel everyone has joined in. Hello, Vijay. Good evening, Na. Good evening, Soumya. Good evening, Lochi. Hello, Junaid. Hello. We start at 7:10. Till now, you guys can uh, See the house robber problem on lead code. So I think everyone has joined in. Hello everyone, welcome to the day 2 of this bootcamp. Today we'll be talking about more DP, more 1D DP problems. Uh, we'll be diving deep into 1D DP. We'll be doing some problems of 1D DP and then we'll be going uh, forward towards 2D DP, just an extension of 1D DP, just in when we need when the problem becomes a little complex, we need a 2D array to store our states, and then we'll see how to incorporate every idea in solving DP on subsequences. Okay, hello, and I gave you a homework problem yesterday. So can someone in the chat tell me what did they think of, what was the approach they thought of yesterday? This was the problem. I hope it is visible to all. You guys can see the problem. You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each one of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses are broken into on the same day. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob without alerting the police. 2D DP array. Vijit says he used 2D DP array to solve it. The constraints allow a 2D DP. Yes, constraints are allowing a 2D DP array. Okay. Yes, Biswajit. We are going to discuss the solution using 1D DP array only. So let's see. You guys should try and mention your approach in the chat so that I can correct your thinking where you are going wrong. So even if you have thought of a wrong approach, try to write it in the chat. Try to be as concise as possible and as clear as possible, concise and clear, so that I can clear your doubt. Yes, Suruchi, yes, Dave, you are right. Exactly. Let more people think of. Just add the number, this and this, and compare. Okay, Shashank, just add the numbers adjacent indices and compare. Compare with what? Yes, exactly. Vishwas, you are right. All right, so we should start this problem. I think you guys have thought of decent number of approaches. I have come up with decent number of approaches. Let's try and think of how we can solve it. My screen is visible to all, right? I hope my screen is visible to all. So the problem is house robber. Now try to imagine it like this. You have got houses stacked on a number line, and the thief is standing here. So the only constraint is that he cannot rob two adjacent houses. This cannot happen if these two are robbed. So this this is valid. Alternate hopping is valid. Even this is valid. But any scenario where two adjacent houses are there, this is not valid, right? Do you guys understand this? Why why this alternate is valid? Sorry, why this alternate is valid, and if this happens, then this is not valid because two adjacent houses are robbed. Yes, exactly. Because adjacent is not allowed. Yes, this was right. So so you just have to try to think of a transition function, recursive function, which prevents this adjacency. Prevents this adjacency. So we will try to create, let's say, ith maximum amount he stole if houses till ith one were present. Do you guys understand how I am trying to form this DP problem? First, I have formulated the condition that two adjacent houses cannot be robbed together, and then I have tried to return the write the state, how I'm defining the state of my DP array. Okay, is this clear? Okay, Tanya says yes. Is it clear to everyone how we are trying to create define the state, one state in our array, what it will define? Okay, so so if this is the definition, then we can clearly see our answer will be DP of n, right? DP of n will be the answer if this is how we are defining the state. Maximum amount he stole if houses till ith1 were present, and then DP of n will be the answer for the whole problem because n houses are present. Okay, so we define our recursive function something like this. See, there are two cases. Either he robs that house or he doesn't. Simple as that. Okay. And to be able to be correct for that ith part, we need to take the max of both the possibilities. See, we have divided this problem into sub problem. The sub problem is we are going to solve till some ith house, right? So we have divided that's how we have divided this whole problem of n houses into sub problems. So first we will solve till first house, then second house, then third house, and fourth, and then from that we're going to come up with a solution for nth house till n houses. So clearly dp of 0 will be equal to 0. dp of 1 will be equal to nums of 1. These will be our base cases. I hope this is clear from here. Like if only this house was present, you simply rob it, right? Because the amount is positive, so you are always going to get a gain of some money. And if there are no houses, then there's nothing to gain. So the answer is 0. Exactly. So we define, and now this is the important step for every DP problem. This will be the important step. How do you define the transition function? Transition function basically means how you are going to transition into the next state, right? How you are going to transition into the ith state if you have processed I minus 1 states. So let's see. Assuming that you have processed all the states till I, not including I, then dp of I can be written somewhat like this: max of dp of I minus 1, okay, I minus 2 plus nums of I. Is this clear? Yes, Arpit, you are right. We can also transit from last to first. Yes, exactly. Try to see these transition functions. Try to see, is there any doubt in what we are trying to do? From last to first will be more lengthy. Not exactly, Saurabh. If you think about it, it will take the same time complexity. Like basically top to down, top to bottom or bottom to up, two type of dynamic programming approaches. They both yield the same result. There is no problem at all in using any of them. Fine to think about it now. Like if it would have been top to bottom, then we would have taken dp of n as nums of n and dp of n minus 1 equal to max of nums n minus 1 comma nums n. These would have been our base cases, and then we would have proceeded like this, assuming that I plus 1 states are uh, I plus 1 states after I have been processed. So then you write your transition function something like this: dp is equal to dp of I is equal to max of dp of I plus 1 comma dp of I plus 2 plus nums of I. You write it something like this. Okay. Nitin, see, think about it. If you are standing at this position, I call this the ith position. Okay. Okay, Vishal, I'm explaining it. Uh, this is I minus 1, this is I minus 2. Now constraint has always also has given you that every element in nums I is greater than equal to 0 and less than equal to something 400 or something maybe, and n is less than equal to 100, greater than equal to 0, which means nums of I is always positive. Okay, so we can say for sure that if you're standing on, if you have processed till I minus 1, you have the answers for I minus 1. Answers of what question? This is the question we are asking at every stage. Maximum amount he stole if houses till I were present. So maximum amount is told till the house I minus 1 is stored in some DP array here. It is stored. It might be some x value here. Here it might be some x I minus 1 value here. It might be some x minus 2 value. Right? Okay. This might be stored in some DP array. You're trying to process this I minus 1th entry. So let's see how we will process it. You are either saying either I will skip it or um, I will just uh, rob this one. I will rob this, rob or skip. So we are taking two conditions. Either you rob, either you skip. So if you skip, right? If you skip, then think about it. The maximum value which was retained here, it stays the same, right? In case of skip, so in case of skip, the maximum value is same. The maximum value in I minus 1 stays the same. Okay. And if you rob, if you choose to rob, then you rob from here. This is the closest you can rob from. You must have been the max value must have been here, and then you rob. Is this clear? Is this clear how we have come up to this transition function? Okay, it's clear to Vishal. Okay. So if this is clear to everyone, let's try and code this. Uh, First we DP array. Okay, first let's nums dot size. It is visible to all, right? Whatever I'm coding, or maybe I should zoom in. I hope this is visible to all. Okay. So then plus one, let's keep it 0. Then dp of 1 will be equal to nums of dp of 1 will be equal to nums of 0 for int I equal to, then we're starting with 2, I less than n, I plus plus. Actually we're starting with 1. Is this clear? I've just uh, coded the same solution that we discussed. I mean, there have been some changes in in my code, and this is because we have taken this is zero indexed array, and in our approach it was one index. We need to have base case for size 0 and size 1. Actually, I believe, um, just give me a second. I believe it's fine, like it should run because you can see in the constraints, the length is always at least one. It is always at least one. I mean, if there would have been a case, it would have been zero. Then, like I feel Pradeep, you are talking about this. So the length is um, the length is at least one. So if the length would have been zero, then our DP array DP we are defining as n plus one, right? So DP array would have been of size one, and then we are accessing DP of one. This would have been an issue, but the length is at least one, so we can always access DP of one. Okay. So I feel this should be okay. Let's see. Yeah. So our test case, every test case is passed. I hope it's clear to everyone. If there is any doubt to anyone, please ask it in the chat. Then we will proceed towards the next question. Is there any doubt? Yes, yes. If there is any doubt, then you can ask and wait. Till in the meantime, someone who has doubt in this one, they can ask. In the meantime, I will just display the next problem we will be solving. So I've solved it before. Uh, this will be the problem we will be solving, the edit distance problem. Okay. Saurabh says now we have to rebuild it before. Saurabh, time complexity cannot be improved, but you pointed out right that space complexity we can improve. Like, let me show you how. Let me show you how you can improve the space complexity of this. You have to, in order to, I think Saurabh pointed it out rightly, that think about it. For every state, you just need one state before and one more state before. Like you need two previous states, just two previous states. So think about it, like you can simply take three variables and the work is done. Think about it. Zaida, I have mentioned the important transition functions here. And this is the core algorithm. We are talking in terms of algorithm here. We are just uh, preferring C++. We cannot code for every language. It will waste some unnecessary time. So that's why I'm discussing on the writing tablet. I'm discussing just the algorithm part. Algorithm part, then you can apply in any language you want: Python, Java, C++, right? So yeah, where were we? We were talking about optimizing for space. Think about it. For every ith entry, you just need two states. Think about it. Are you guys trying to feel what I'm trying to say? Like you just need two states. So why do you need to store this whole piece of junk? right? Sayed says one more you can explain, sir. Uh, Sayed, I will just give you a brief overview. We are trying to solve this problem. We have defined the state like this: DP of I means maximum amount he stole if houses till I were present. So we have n houses. We are trying to break it into sub problem like till ith house was present, like for till first house, till second house, till third house. And then if by this definition, the answer will be DP of n because n houses will be present. Right. Now we come up to the base case. DP of 0 is obviously 0. If 0 houses are present, then there is nothing to stole. DP of 1, if there is only one house present to stole, then we stole it. Then we steal it. Why? Because we are given that the money is always positive. So it's always beneficiary to stole that house. If there would have been a case that money was allowed to be negative, then you would have been a little careful here, because then you cannot write DP of 1 is equal to nums of 1 if this entry would have been negative. Then and keep in mind that we are taking nums as one indexed array, varna we would have been taken DP of 0 here, the one indexed array. um, okay, or maybe for the confusion, because we are taking DP of 0 as 0 indexed, so let's take it as 0 indexed. This is the first house we are going to. This is okay. Now both arrays are 0 indexed. I've just changed the indexing. That's it. Okay. I hope it's clear. So yes, Saurabh, you pointed it out right that we can optimize the space complexity. Do you guys want me to show you how you can optimize the space complexity in the code? I can show you that. Just tell me if you guys want to see it or not. Pradeep says yes. Hazel says yes. Okay. Okay, then I will just quickly show you. You can simply remove this and then do the int dummy1 equal to 0, dummy2 equal to nums of 0. Now think about it. Changed, we have changed nothing. These are our base conditions, right? Okay, I will sort of I'm showing it to you. You can try it in the next problems. Try it on your own in the next problems. For this I will show, because some of you might be confused how you can optimize it. Okay, this was by DP. Now create another temporary variable which goes something like this: max of dummy of 2, comma dummy of 1 plus nums of I minus 1. Okay, I hope this is clear. And then replace dummy1 equal to dummy2 and put dummy2 equal to temp. And then at the end, you simply return dummy2. I will see. Oh, now now it beats 100%. I think they were expecting this optimization. I did not really stress about it because interviewer, uh, I think, doesn't really focuses on this. He wants to see if you can build the logic of it, if you can build the logic from the scratch, how you are going to solve it. Yes, it's amazing. We have by removing. Can you guys see that by removing this line we have saved O of n space. Now this becomes O of 1 space and O of n time complexity. Right. Is this clear to everyone, or is there any other doubt? If there is not any doubt, please tell me if it is clear in the chat. Rameshwar says yes. Arpit says yes. Tanya says yes. Okay, okay. Quick, then we'll move on to the next problem. It's waiting. Vishal, it's clear to Vishal. Saurabh, okay, it's clear to you. Okay, Anshid, okay, Dev. Okay, I feel like it's time we should move on to the next problem. Okay, Pradeep, okay, Bhavika, understood. Sanidhya, Ananya, Sayed. Okay, next problem. So read this problem. It's a very famous problem. I first solved it personally in one of the assignments uh, in one of the algorithm course in my college. It's a very famous problem, historical one. Uh, so I will try to tell you what the story of the problem. Try to read it. I'll just give you 2 minutes to read the problem. The problem is quite small. Okay, we have a solution. We have an idea from Arpit. Yes, Bhavika, optimization was needed in the house robber problem. They were expecting optimization, I guess, because then you would have noticed that in the second submission, that was actually the best submission. It beats 100% of the users. Um, so yeah, if recruiter asks for further space optimization, you can basically try to catch this idea that in some problems you will be. I will just give you a trick how to identify if you can space optimize or not. Just identify if in a DP problem you are trying to use a finite number of states. Like from I, you are just trying to go till the last two states, till the last three states. You're not traversing the entire array for that I. Then you can space optimize. Think about it. If you're just using two, then the last n minus from n minus three, the last n minus three values, they are obsolete, right? They are not needed. Okay, it's clear to Janvi. Okay. Pradeep, you are going into the right direction. Yes, yes, yes. Okay, so um, think about this problem. A hint for you all is this is not solvable by 1D DP. You can also you can also see the constraints here for the problem. I mean, in my this is the small thing I used to do when I was new to DP, that I used to see these whenever I used to see 500 limit, I also always used to think, oh, it's 2D, two-dimensional DP, because till 5000 10 is power 3, uh, 2D DP is allowed, because 10 cross 3, 10 is power 3 cross 10 is power 3 is 10 is power 6. Okay, so everyone has read the problem. So let's try to think about. Given two strings, word 1, words 2, written the minimum number of operations required to convert word 1 to word 2. Okay. So you have to you can insert a character, delete a character, or replace a character. Okay. 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 So yes, Bhavika, you are going into the exactly right direction. So let's see how the transition functions for this one will look like. Let me share my screen. I hope the screen is visible to all. So this question is edit distance. It depends on the transition functions you are using. Arpit. If you can maybe mention them in the chat, we can verify if your approach is correct or not. Okay, so you have to basically convert one string w words 1 into words 2. And let's pick the first example. It says horse to Ross. I mean, I hope this is the correct. Oh, okay, this is sorry. Now think about it. How you will proceed in this problem? You will proceed in such a way. First, let's see how you can convert horse to Ross. So, first conversion can be something like this, and then you simply remove. This is the first step, this is the second step, this is the third step. Mm, is this clear? Think about it. So you can think about it in such a way. Okay. Um, if you can match, because you are given three operations: insert, delete, uh, insert, delete, and replace. You can simply match a substring from here to a substring from here. Do you realize this? Like here, what is that substring? OS matches with OS. Uh, RS matches with RS. So maximum matching we get is 2, right? And maybe we can do something like max of S1 comma X2 minus max matching. S1 and S2 are the sizes 5 and 3. So here 5 minus 2, which comes out to be 3. We can do something like this. If this is clear, like you can see in the first test case here, they are doing the same thing. Maximum matching we get is OS and RS. The maximum matching is 2, and biggest size is of horse, so 5, and 5 minus 2 is 3. Same goes in intention and execution. Maximum matching is TION. Like I can spot it from here. I don't think there is a matching of more than 2. Is there matching of more than 2? No, there is not. Think about it. Yes, Shraddha, you are right. This is subsequence matching. We are kind of tending towards that subsequence problem. In fact, we are on subsequence problem. I'm just trying to give you a flavor of subsequence problems and 2DDP problem together, because I think we have already spent a lot of time on optimizing this one problem. So let's think of it. Matching is not work. Can you please elaborate, Syed, what you're trying to say? Okay, so if you guys understood this, what I kind of do is, for every I in the second string, I compare it with all the J's. So here must be S of 1, S of 2. Now look closely how for every I compare it for all. Okay. We compare it for all, and how we will be defining our DP? We will be defining why I took edit distance as the first problem for our 2D DP is here applying 2D DP is very intuitive because we have two strings, right? And the state I'm going to define is very intuitive as well. Answer for words 0 to I and word 1. Actually, this is word 1. Word 2, 0 to J. Okay. Does this make sense? Now think about it. Think about it in such a way that how will the transition function look like? First, is this thing clear to everyone? How I have defined this state? It's clear to Pradeep. Just tell me in the chat if. Okay, Sayed. I will try to explain this again. Okay, DP of I comma j is, this is a 2D array first of all. For example, for 5 and 3 I will show you. For 5 and 3 this DP array looks like this: 5 and 3. Okay, like something like this. We will construct the whole matrix, but now it will look like this: H O R S E R O S. This is how that 2D DP array will be. And just to handle that empty string condition, we'll be constructing for one more size for every string. It will be something like HORSE ROS. This will be empty. This will be empty. Got it? Okay. Okay. I hope it's clear for everyone. If it's not, okay. So while solving for DP of I comma j, we will assume that we have answer. Except maybe I should. Let's solve it for horse. Uh, solve it for that example. HORSEROS. Okay. Now what DP of I comma j is representing? Answer for, okay, it's clear to Pankaj, clear to Tanya, it's clear to Deepika, okay, clear to Paul, clear to Pradeep, clear to Zaida. Nice. I hope you guys are following because this is really important. This will help us in doing further problems. This edit distance problem actually helps us in solving further more problems on strings. So, okay, it's clear today, Dave. Nice. So please listen to me carefully while I'm solving this. This will obviously be zero. Both strings are zero. Okay, think about it. If you have h and other string is empty, how many operations will you need to make both of them equal? Think about it. Answer in the chat. How many operations? If h, one is h, and other one is empty. How many operations will you need? And then try to think about this whole row. What should be the answer for this whole row? Like when this represent, this box represent when the string is HO and other is empty. This represent when the string is HOR and the other one is empty. So try to think about for the whole row. Yes, Pradeep. Yes, Blesu, you are right. Yes, Arpit. Um, so this is N. This is M. Yes, everyone, you are thinking in the right direction. Yes, Tanya, right. So 2, 3, 4, 5. We can simply fill this row, right? I hope this is clear to all. That we can simply um, fill this row with this, and then we can start from here, and this will become our base condition. That if one string is empty and another string is not, this will be our base case for this. Okay. Yes, Prakhar, you are right. So for now, think about for this. Think for this. What should be the answer for this? So if I'm solving, this will be 1 comma 0. Okay. So subsequently for this one, I can again write this. Is it clear to all? Yes, Arpit, I'm solving it iteratively. Yes. So subsequently for this, I can write this, and for this, I can write this. Right. Okay. So think about the answer for this. H and R. Think about the answer for this. Think about if what I was saying earlier. If there is a string, we take substring prefix of this and some prefix of this. If the next endpoints match, then our answer should not increase. Then we don't need to make any changes, right? If they match, and if they don't, then our answer increase by one. Think about it. Think about it. Try to convince yourself that let's take HOR and R. So if we have answer for HO and empty string, R doesn't make any difference. R doesn't make any difference. We can simply uh, we can simply copy the answer of HO and empty string to be equal to DP of, obviously that's not how you access an array in any language. Um, Convince yourself for this. Is it clear? Yes, it's clear to Rameshwar, clear to Bhavika, okay. It's clear to rest of you or not that this will hold. I have written this in this form so that it becomes clear what sometimes thinking in terms of indices becomes a little confusing. So I have written it in form of this. Is it clear to all? Yes. So we can simply think of one simple transition के dp of I comma j. Okay, maybe I should write it like this. So if w1 of I equal to w1 of j, then dp of I comma j equal to dp of I minus 1 comma j minus 1. Else dp of I comma j equal to dp of I minus 1 dp of j minus 1 plus 1. So these transition functions are clear to all, right? Okay, so the attendance link is in the chat. You can mark your attendance. Quickly mark the attendance and then think about this. From this example, I convinced you all that this is correct. W1 is simply words 1 and words 2. And just word 1 and word 2, I just use a short form for this. Is it fine to everyone? There is any doubt in the transition function? You can ask it in the chat, or if it is clear, then you can say yes or thumbs up. Is it clear to all? Is there any doubt in the transition function? If not, then we can simply code this out, this solution. Let's try and code it. Simply create a vector of int known as dp int n is equal to w1 dot size comma n to w2 dot size. Okay, so n plus 1 comma vector int n plus 1 comma 0. Okay, it's clear to Bhavika, it's clear to Vaishu, it's clear to Anime, it's clear to Pradeep. Nice, nice. Amazing guys, amazing. If you're trying to understand it, amazing. This means you're trying to put effort. This will be because this will be your first problem in 2D I understand it will be a little complex, but the next two problems we are going to do, they're going to be pretty simple. So if you guys are able to understand this, so just bear with the tough part, then the life is pretty simple. Then I think I should put comments. So let's base cases for int I equal to 0, I less than equal to n plus plus dp of I comma 0 equal to I for int I equal to 0, I less than equal to n dp of 0. Okay, Balaji, let me code this solution and then I will explain once more. Just I will give a brief recap and then you can ask your doubt. First, let's just code this solution for int I equal to 0, I less than. Now we can start from 1, right? Okay, so we have written the transition functions correctly. I believe this should give the right answer. Oh, so this is giving output as 1. What are we missing in this? Let's see. Make a deep J. Let's print the matrix. What are we missing in the matrix? Okay, so this is initialized correctly. This is initialized correctly. If condition looks to be an issue. Okay, let's check what's the issue with if condition. Hmm, are we checking it again and again? Is there an issue there? Or maybe not. Let's try and debug this quickly. Alright, so what we are trying to do here is not able to see my code. Okay, I will make this like this and zoom it a bit. Now you must be able to see it, right? I hope now it's visible. We have done taken minimum here. What can be the issue? Hmm, okay, maybe I found the issue. Indexing was the issue most probably. Our approach is correct for this. Due to the minimum, okay, here we missed the minimum condition. Oh, most probably now it will error. What's the error in this? Comma J. Let me think of the error. What can we miss? Loop boundary is not correct. I mean, they are correct. We are using I minus 1 and j minus 1 for W and W2. Yes, yes. So if it's not equal, then we should take the minimum of these three conditions and add one, because you can see, right? Either we have to delete in this one, either we have to delete uh, in this one, either we have to delete the jth, in this one, either we have to delete ith, and in this one, maybe we have to change jth to ith. Do you understand this? Yes, Arpit, you are right. This was the issue. Earlier, it was written like this. This was for debugging our metrics. I believe this should work fine. Yep, it works absolutely fine for this. Just tell me if you have any doubt in this problem. I myself got a bit confused. Um, Earlier, indexing was not the only issue. Um, we actually earlier we were doing this separately. Now I have done this together. So if there is any doubt, you can ask. Line 13 plus 1 not required. Yes, you are right, Pradeep. That was the error. That was the error. Yes. Is there any doubt? Yes, Pradeep. Yes, Arpit. Yes, Bhavika. You all pointed it out correctly. Um, that was the error. Exactly. Is there any doubt in this problem? If there is one, you can explain it. Okay. Okay, Sayed. Okay. Both conditions may plus one. Not exactly. Like, okay, let me just go through it, go through the whole problem once again quickly. Um, Now the issue was we were just seeing this HOR, HOR and something here R, and if we are matching it with this, then the answer for this should remain for the answer for this. Like, we came to a conclusion like this, right? If they are equal, then we can simply do this. We already discussed it, right? So there is no need to add one in the condition where both of the characters are equal, because then we can simply take the previous answer, because after all we are calculating minimum, right? I hope it's clear. Okay, Sayed. Okay. So our transition function kind of looks like this. First, we created the base conditions. Okay. Then the first condition in the transition function is quite simple. Like, see this example, HOR and R. So whatever you did for HO and this empty string, the answer remains the same for HOR and R. So because you don't really have to change R, you just have to take care of this and empty string part, right? So this is the first condition. If they are not equal, for example, not equal like HOR and S, please explain third for loop. Yes, I'm explaining the third for loop. Okay. So the third for loop goes something like this. DP of okay, I might write the else condition here. DP of I comma j equal to minimum of dp of I minus 1, j minus 1, dp of I minus 1, j, dp of I, j minus 1 plus 1. This was the else condition. I hope the if condition is clear to all. I'm trying to explain the else condition now. I hope the if condition is clear. Is the if condition clear? Because it's clear from this example. You simply do copy the answer for I minus 1. Okay, I will explain the fourth for loop also. Fourth loop was only to debug. I was just printing the matrix uh, to check where is the problem. The first two for loops are for these base conditions, and then there is a nested loop I for I and j for going to every uh, entry of this matrix. Okay, now let's quickly think about this. This can be an okay. So we are simply matching for the last character of the substring till I till j I till j. This is the jth entry, this is the ith entry. That's what we are doing. This is words 1, this is words 2. Okay. So and for every this element, we're trying to see if they're equal or not. If they're equal, then it's pretty simple. You simply do what you did for the truncated part. Truncate the last characters and simply copy the value. Okay. And if not, then see, either remove this or remove this or replace this with this. There are just three conditions to try and make this equal, right? These are the three conditions. So we are trying to replace, we're trying to delete this ith entry. That's why we are taking the answer for I minus 1 to j, deleting the j minus 1th entry. You can think of it as inclusion exclusion. For I and j, take, remove, take, and for this, basically you are removing both. Think of it like this. Is it clear? That's why these three conditions. That's why these three conditions. I hope this is clear to all. Is it clear to all? And you know what? You can simply um, okay, it's clear to Pradeep. Okay, you can simply think about it. You are always using -1. You're always using the last processed row of this. For if you're computing this row, you're only using this row. Think about it. So you can even argue of for in space optimization in which you will only be using the previous row. So you can maybe create a vector int previous and then create a new and then replace this previous with new like this, or maybe something similar you can do. All right, all right. So let's quickly discuss the next problem, the unique path problem. Oops. It's a pretty simple problem. The problem states that a robot can only go down and right. You have to tell the ways in which he can reach to the finish. The time he needs to reach to uh, the finish point, and finish point is n-1, comma m-1. Think about it. Come on, guys. The last problem of the day. Last problem of the day. You will feel confident for 2D DP with this one. Try to think about it and answer in the chat if you are able to come up with a solution. Okay, Pankaj, try to think of the solution. Did you guys come up to any solution for this? Or shall I discuss? Come on, be quick. This is the last problem, so don't put your head down. Head down. Zoom it. Okay. Let me just show you the problem. This is the problem. Yes, Arpit, it is easier than last. You are right. The reason of topics. It is not clear what you are trying to ask, Shraddha. So maybe if you can ask it clearly. Okay, Arpit says unique path sum of. Yes, right, Arpit, you're thinking in the right direction, right? Amazing, amazing. Yes, this is classic rat maze. Maybe we should discuss it now. You guys can think of the answer. Think of the approach. So the question is uh, number of ways to reach finish. Constraint is you can only go this or this. These are the constraints. Okay, it's quite simple if you think about it. Um, what will the base case? The base case will be the only way to reach 0, comma 0 is 1, right? And to reach dp of and to reach I comma j, you can only reach from two ways. So add dp of I minus 1 j plus dp of I j minus 1, right? Yes, Debajyoti, right? Yes, Pradeep. Yes, Bhavika. Yes, Arpit. You all are right. If j equal to. Yes, exactly. This is a transition function. And this is how we have defined answer if I comma j was final, was not final, was the finish point. This is how we have defined dp of I comma j. Is there any doubt? Because this is pretty simple. This is simpler than the last problem. This the transition function is pretty simple in this case, right? So let me just quickly code the solution. Actually, we can simply do this one thing. Oh, And now we can start it from 1. Oh, we don't really have to take the mod in this case. Okay, then it's pretty simple. I guess we can simply return n minus 1, n minus 1. Oh, return. Oops, what happened? Oh, did we miss something? Okay, we can simply print. Let's try and print the DP array. Okay, there is one way. There are two ways. Hmm, it's just one way to use this. Yes, now it works fine. No, the problem was I was defining the base case incorrectly. The first row and the first column is just one way. Just keep for any point in the, like, look at this. In any point in this column, just keep going down, or in any point in this row, just keep moving towards right. So for every point in the first row and every point for the first column, the answer is 1, and we had previously written I. That was the problem. Okay, Pradeep. So this is the solution. And again, you can space optimize it. See, we are always using I minus 1th row, just the previous row. So you can space optimize this from n square to O of n. Okay. So try to think about the space optimized solution for this problem. And that's it for today, guys. That's it for today. Tomorrow we will be doing more tough problems on DP, and we will be starting graphs as well. So tomorrow there is a very important day. Tomorrow we will be starting graphs, and we will be doing some tough problems for in DP. So in the starting section we will be doing tough problems of DP, and then the next section we will be starting graphs. So till now we have done some quite famous and standard problems in 2D DP. Edit distance was one famous one. This unique path is also a famous problem. You all can try this problem. Unique path in um, what was the name of the problem? I forgot. You all can try this problem, the minimum path sum. We will discuss this problem in the next class. So try to think about the approach for this problem, minimum path sum. Okay. try to think about the approach, and we will do some variation on this problem. Minimum path sum. It's like we will do this problem as well. This is a little tougher version of this problem. So try to solve this problem first, and then try to look at this problem. Okay. So that's it for today. If someone has doubt in the last problem we discussed, he can ask it in the chat, and otherwise we will wrap the session for today. Welcome Saurav, welcome Dev, welcome Pradeep. Yes, Arpit, you can try that problem as well. Maybe if you try it before the next class, we can discuss your doubts. Welcome Vishal. Okay, bye everyone. Have a nice evening. We will meet tomorrow. We will try to finish DP. We will try to introduce graphs. A very amazing topic, very important one. Um, welcome Debejyoti. Welcome. Okay, bye everyone. Okay. If you have any doubt, you can stay and ask. Otherwise, we are finishing the session. If there is no doubt, then you can leave. Tomorrow we'll be starting with graphs, and we'll be doing some really amazing problems of dynamic programming. So come prepared. Try to do those two problems I mentioned, the minimum path sum and a follow through. Welcome Bhavika. Rishi, the knapsack, if you think about it, we already did it. The inclusion exclusion uh, approach that we discussed was kind of based on that only. Welcome Rajshri, welcome. Okay, so we will end it here. Um, we will end it here. So bye everyone. We will meet tomorrow at the same time, 7 p.m. to discuss some tough problems of DP, and we will introduce ourselves to the world of graphs. Okay, bye bye.